Welcome to Taxonomy Online Mathematics. In this episode, we had a question and vectors that came in WASSCE November 2007. So we are having P is a vector of 2 and negative 1, Q is 1 and 3, and R is 5 and negative 6. So our task is to find the value of M and N such that the R, which is this vector, is equals to a scalar multiple of M and P plus a scalar multiple of what? N and Q. So where M and N are just what? Scalar multiplication. So what do we do? For the A, we are going to have our R equals to MP plus NQ. So we know the vector for R, which is going to be 5 and negative 6, which is equals to a scalar multiple of P, 2 negative 1, plus a scalar multiple of Q, which will be 1 and what? 3. We know if you are doing scalar multiplication of vectors, the scalar multiple multiply each of the vector. So that means your 5 negative 6 will be equal to M times 2 will give you what? 2M, M times 1, which is negative number, so we give you negative M. Then we are going to have plus the N will also multiply the 1, give us N, N times 3 will be what? 3N. So this become the product, or like the result. What do? We need to find the arithmetic of this. So this becomes 5 minus 6 as a vector equals to 2M plus N minus M plus 3N. So this becomes 2 vectors. This is equal to this. It becomes equality of vectors, meaning the left equals to the right. Simply put, 5 is equal to 2M plus N. It means if I know the value of M and the N, if I add, I should be able to get 5. The same way, the value of M and N in this arithmetic will give us what? Minus 6. So this becomes equality of vectors. So equating corresponding vectors, we are going to have 5 equals to 2M plus N. And we can see this become an equation. This become the first equation. Minus 6 will be equal to minus M plus 3N, which also become what? Equation 2. We now solve these two equations simultaneously, looking for the M and what? N. Now, we can do elimination or substitution. If I want to eliminate the M, it means I have to make sure the coefficient of M are the same. In this case, I have 1 here, I have what? 2. So I multiply equation 2 by 2 in order to make the coefficient in the equation 2 of M to be what? 2. So we have equation 2 times 2. So I'll still have this being maintained. 5 equals to 2M plus N, my equation 1, equation 2. So 2 multiplying every term. 2 times minus 6 minus 12. 2 times minus M minus 2M plus 2 times 3N will be 6N. That becomes equation 3. So I want to eliminate what? M. And it will be easy to eliminate if they have the same coefficient. So 2, 2. But if the signs of the coefficient are different, I can eliminate by adding. 2 minus 2 will give me 0. So I will be having equation 1 plus equation 3. So 5 plus minus 12, that will be minus 7, equals to, right here will be 0. This will give us what? 7. 6 plus 1 will be what? 7. So 7N. So it means that I need to find the value of N by dividing by the coefficient. So right here, I'll be having negative 7 over 7, 7n over 7. That implies that negative 1 equals what? N. When negative 1 is equal to n, it also means n is equal to negative 1. So one of the variable is known. We substitute into either equation 1 or equation 2 in order to find the m. So here, put n equals to negative 1 into equation 2. Going to be this. Minus 6 equals to minus m plus what? 3n. And negative 1 will multiply the 3 to give you minus 3 what? N. But the n is also negative, so negative 1. So that gives us what? 3. For us to be able to eliminate minus 3, what do? We add 3 to both sides. If I add 3 here, this will go. Then this becomes minus 6 plus 3. So minus 6 plus 3 equals to minus m. That implies that right here I'll have minus 3. So minus 3 will be equal to minus m. But I'm looking for a positive value of m, not a negative. So what do? We divide by the negative 1 or multiply through by negative 1. So negative 1 dividing it, make your m to be equal to what? 3. So m is 3 and n is what? Minus 1. So that's the value we are asked to find. So we are done with the first part. The second part is saying that we have to find the magnitude of g. If g is also a vector equals to 3 times what? Q plus r. Meaning I replace r by each vector, replace q by each vector, then I can find that of what? R. Then at the end, I should find the bearing of the vector r, q that I'll be finding. So right here we have our g equals to 3q, which is going to be 1 and what? 3 plus what? R, which will be 5 minus what? 6. So right here there will be a multiplication. So g will be equal to 3 times 1 will be 3. 3 will give us what? 9. That will be plus 5 minus what? 6. Since we are adding the vectors, that will become 3 plus 5, 9 plus minus 6. Okay, so let's see what the value of vector g will be. 3 plus 5 will be 8. 9 minus 6 will be 3. So this is the vector g. But our attention is on magnitude of g. Therefore, the magnitude of g will be the square root of x squared plus y squared. Meaning the x coordinate will be 8, y coordinate will be 3. And we know that if you square 8, you will get 64. If you square 3, you will get 9. So in that case, this gives us the root of, that will be 6 here, so 73. And that will be in the vein of 8.54. So right here, finding the magnitude of the vector g is just 8.54 unit, whatever unit that will be assigned to that. That will be 4, finding the magnitude. Then we are asked to find the bearing of g. Don't forget the bearing of g is on 8 and 3. If I take my Cartesian plane, we know 8 on the x-axis, 3 on the y-axis. So I will have, let's say, here from here to here is 8, and from here to here is what? 3 and 8. If I have where they meet here, finding bearing, meaning going to the north and measure until you meet the point where the line joining the 2 points. So this is where the 8 and 3 meet. So I'm looking for this bearing, the movement, the direction from this side up to this. But I can easily find here, since this can form a right angle triangle. So if I find the angle theta, I know from here all the way to this place will give me what? 90 degrees. That is from the north, west, and east. So in between the north and east, I have an angle of 90 degrees, right? So if I know the angle theta plus whatever the angle here will be, that will give me 90. So it also means that 90 minus theta give me what I'm looking for. Don't forget, this is parallel to this, so it also be what? 3. So right away, I can use trigonometric functions, making use of opposite and adjacent. That will be 2. So tan theta will be equals to the opposite side over the adjacent. So from here, we have tan theta equals to opposite side over the adjacent. And we are looking for tan. And we are looking for theta, right? So theta equals to tan inverse of 3 out of 8. And on our calculator, that will give us 20.56 degree. So the angle theta here is going to be 20.56. This plus this will give us a 90. Therefore, the bearing of G is going to be 90 degrees minus 20.56 degree. And that will give us 69.44 degree to 2 decimal places. So the bearing of the vector G is from the North Pole to the line joining the point at the origin. The point and the origin. And this is from the north plus 20.56 to give us 90 degrees. So in all, in this question, we are able to find how to add vectors, how to multiply, that is a scalar multiple of a vectors. We learn how to find the magnitude of a vector and also finding the direction, which is the bearing of the vector. I believe this question encompasses a lot, and if you're able to grab the concept, you should be able to do a lot of questions under vectors. Thank you for watching. Like, share, and comment. Bye-bye.